Once the RNA has been processed and exported from the nucleus, it heads out to the cytoplasm to be picked up by a ribosome for translation. Just like transcription, translation also has 3 steps: a beginning, a middle, and an end: initiation, elongation, and termination. Initiation begins when the small subunit of the ribosome sits down on the 5' end of the mRNA and scans along until it meets the start codon, which is read 5' to 3' AUG. The small subunit of the ribosome stops at the start codon, and then the initiator tRNA complementary base pairs with the start codon. The part of the tRNA that complementary base pairs with the start codon is called the anticodon. And so it lines up anti-parallel 3' to 5' UAC with the start codon. Once the tRNA is attached, the large subunit of the ribosome can attach as well. For elongation, the ribosome slides down the mRNA 5' to 3', reading the mRNA in groups of 3 called codons. The tRNA that has the methionine amino acid attached is in the P site, or the peptide site. New tRNAs come in to the A site carrying new amino acids, and the amino acids are joined up to the growing peptide chain from the N terminus to the C terminus. It's the ribosome that catalyzes formation of the peptide bond. Once the amino acid has been joined to the growing peptide, the ribosome slides down 3 nucleotides, or 1 codon. The empty tRNA is now moved to the E site, or the exit site. The peptide with a new amino acid is now slid over to the P site, and there's room for a new tRNA to enter at the A site carrying a new amino acid. And this process repeats. This process continues until the ribosome reaches a stop codon. There are 3 different stop codons. Instead of a tRNA attaching to the stop codon, a release factor attaches, and the peptide is passed to water instead of a new amino acid. The protein is released, the subunits of the ribosome dissociate from the mRNA, and that mRNA can be read again to make more of the same protein, and those ribosomal subunits can be used to synthesize new proteins on the same or a different mRNA. Your homework is to fill out this chart comparing DNA replication, transcription, and translation. For each of them, consider: where does each process start? What is the major enzyme responsible for doing this process? What other molecules are necessary for these processes? Where do they stop? And which direction does synthesis go?